Let's go to page 364, and this is lesson 6.2. And this lesson is to use proportions to solve geometry problems. Okay, so in lesson 6.1, you learn to use the cross product property to write equations that are equivalent to give proportions. 3 more ways to do this are given by the properties below. So key concept is this: additional properties of proportions. Okay, reciprocal properties. So if 2 ratios are equal, then their reciprocal are also equal. So this says if A over B equal to C over D, then B over A equal to D over C. So basically what you do is you flip it upside down. Okay. And next one, you have A over B equal to C over D, then A over C, so you can switch the B and C. Okay. Next one is you can add something to it. Now, this is seems very confusing, okay? But actually, it's very simple if I can show you how to visualize it. Okay. So with proportions, okay, suppose if you have like 2 transversal and you have lots of parallel lines. Okay, so all these lines are parallel. Okay, so in order to be proportion, this has to be parallel. I'm going to call this length A, B, C, and on here, I'm going to call it X, Y, Z. Okay, so the way the proportion works is that you can write the proportion equation any way you want as long as you match it up. So I'm going to give you some examples, okay? So for example, you can have an A over B. So A over B, this will equal to X over Y. As long as you match up, see? A match with X, B match with Y, okay? You also can, so you can write it any way you want as long as you match it up. So if, for example, you can have A plus B over B plus C, for example, okay? Well, what will this equal to? Well, A plus B will match with X plus Y, okay? B plus C will match with Y plus Z. So you can see you can do it any way you want. So you can, whatever this side is, you match it up. That's how you write the proportions. Okay? And so you can also switch it the other way. For example, you can have like A over X. So if you have A over X, so now you're going to match this over that, right? So this will equal to B over Y. Okay? Because it's this over that, so equal to this over this. Okay, you see that? So you cannot say this over this equal to this over that. So if you have this side over this side, then you have to have equal this side over this. Okay. So same thing. You can have for example, you can have the A plus B. So you can have this over X plus Y. So if you have these 2 over these 2. This will equal to any of this, so it would be like B plus C over Y plus Z. Okay? So you can write your equation any way you want as long as you match up equally. Okay? Whatever you have on this side, you have to match exactly on the other side. Okay? Then all the equation will be valid. Okay, so that's what this is talking about. This one right over here. You can add anything to it as long as you match it up. Okay? So then if you go back to this again, okay, so you can even have like an A over A plus B plus C, and this will equal to, so since A match with X, so you can have X over, and ABC would be X plus Y plus Z, okay? And if you want to flip upside down, that's fine, okay? So for example, let's say if you have A plus B plus C over C. Okay, well, what will this equal to? Well, you got the A plus B plus C, so that's a whole thing. So it'll be equal to X plus Y plus Z over C will match with Z. Okay, see that? Okay. So that is what this is talking about right over here. Okay? So that's what this is. Okay, you can write it any way you want. Okay, so when you have this kind of problem, if you draw the lines like that, it helps you to visualize, and you can write the equation any way you want without making any mistakes. As long as you whatever you have on this side, you match it up correspondingly, then it would be fine. Okay. Okay. So let's go to example 1. So as long as you understand the proportion, actually it's fairly easy. So like this one, in a diagram, okay, it says Mn over Rs is equal to, so this over this equal to Mp over this. So that's your proportion. So to solve for x, notice that since they are proportional, right? So notice that this is half of that. So this would be half of that, so x will equal to 5. Okay? And it says write 4 true proportions. Okay? So how you write 4 proportions based on this? Okay? Now you get A for 10x, right? So again, if you go back to this picture over here, okay? So the way you're going to do it is it helps you to visualize. So in example 1, so the way you do this is going like this, okay? So you have the 8, 4, 10, x, okay? So to write this again, you can have 8 over 4 equal to 10 over x, or you can have 8 over 8 plus 4 equal to 10 over 10 plus x, right? Or you can have 4 over 8 equal to x over 10, okay? Or you can have 4 over 4 plus 8, so you can have this over the sum equal to x over x plus 10. See that? So that's your 4 different ones, right? So you can write it any way you want, okay? As long as you match up exactly. Okay, notice I'm only doing this way, right? But you also can go across this way. You can have 8 over 10, so this over that will equal to, so you can do the top over bottom this way, or you can do the left over right. So right now you have the left over right, so you have to have a left over right, okay? So again, so you can write a proportion any way you want, okay? And that's how you convert, that's how can you convert this into this kind of picture, okay? And by using this, it helps you to visualize, and you can write a lot of different proportions. Okay. Okay. Okay, let's go to example 2. So this is x. Normally, I try to write the numbers on the inside. When the number on the inside indicate that this is only for this only, okay? So if I have 18 and 6, then the whole thing is 24. So the number on the outside represents the whole thing. If it's only for this part, I kind of write on the inside. So use that as your convention, okay? Okay, so in this diagram, it says that BD over DA equal to BE over EC. So because of proportion, that means these are parallel, okay? In order to, remember from the very first diagram, they have to have parallel to have a proportion. If they're not parallel, then then it's not proportional. Vice versa. If it's not proportional, then it's not parallel. So if they're proportional, they're parallel, and if it's parallel, they're proportional. Okay, so this is key thing to remember. Okay, in order to have proportions, they have to be parallel. Vice versa. Okay, they have to be parallel to have proportions. So by having the proportion, it tells you that these are parallel. Okay, okay. So you're looking for BA. Okay, you're looking for X. Okay, again, you can do the proportion, right? So notice this is half of that. So this will be half of that. So this will equal to 9 already. Right? Again, this is half of that. So this will be half of that. Okay? And this is 3 and 9. So x equal to 12. Okay? See how easy you can do that? Okay? But if you don't know that, you just have to write out the equation like in the book. Okay? So again, you can write the proportion anyway, right? You can have x minus 3. Let's say if you don't know the answer, so you got x minus 3 over 3, right? This over that, x minus 3 over 3 equal to 18 over 6, and you can go and solve, right? So x minus 3 over 3 equal to 3, x minus 3 equal to 9, and plus 3, so x equal to 12, okay? But again, this is wasting a lot of time. You can just write it on your picture, right? So this is 18, this is 6, so this would be 24, okay? And then this is 3, so this is half of that, so this would be half of that, so half of the 18 is 9, and if you got 3 and 9, you get 12, right? So when you drawing make sure when you do this kind of point, it's a lot easier if you draw a big diagram, so you got room to label all your numbers and you can do it very quick. Don't draw your picture so tiny that you cannot even have room to label, okay? So draw a big triangle so you got room to label all the stuff, okay? And again, remember, if it's a partial number, you write it on the inside. If it's the whole length, you write it on the outside. So like 6 is from here to here. Don't write it out here because later on the problem gets complicated, it can be confusing. So whenever you can, write a 6 on the inside so that way you know that 6 is from here to here. Write the 18 on the inside so you know that 18 is from here to here. If you write a number outside, sometimes if you don't know, you may think that 18 is from here to here and you're going to make a mistake, okay? So keep in the habit of doing that, okay? If the whole length, you write a number on the outside. If it's a partial length, you write it on the inside, okay? So again, by drawing the big picture, label everything, you can get an answer super quick, okay? Okay, now let's go to 3. Okay, let's go to example 3. Okay, from the scale of a drawing, okay, blueprint. The blueprint shows a scale drawing of a cell phone. The length of the antenna on the blueprint is 5 centimeters. So you can see that every square equal to 2. Okay? The actual length of the antenna is 2 centimeters. So what is the scale of the blueprint? Okay. Okay. The scale of the blueprint is 5 to 2. Right? So the real one is 5, and since this is mentioned first, and so we're going to use that, right? So it's 5 to 2. Okay. So if you normally you don't want to use decimal, so I don't. It said, okay, to solution to find the scale, write the ratio of the length in the drawing to actual length, then rewrite the ratio so that the denominator is equal to 1. So I guess you divide everything by 2. So 2.5 to 1. Okay, so that's a scale. So whenever talking about a scale, they usually try to get one of the number equal to 1. Okay. Okay. And normally they want you to use the drawing to the actual length. Okay. So the actual length should be kind of on the right hand side, and it should equal to 1. And this is whatever you simplify. Okay. So usually that's how you do the scale. Have the real length equal to 1 and the drawing equal to whatever that you simplify. Okay. Okay, let's go to example 4. Use a scale drawing maps. The scale of the map at right is 1 inch equal to 26 miles. Okay. Find the actual distance from Pocahontas to Algona. Okay, so you're looking for from here to here. Okay. So what you do is use a ruler and measure the distance. Okay, and so by measuring the distance, okay, it says use a ruler. The distance from Pocahontas to Algona on the map is about 1.25 inches. Okay, they x be the actual distance. So you got 1.25, okay, over x miles equal to 1 inch to 26 miles. Okay. So again, when you're doing this, right, when you're doing a proportional, if you don't know what to do, then another way to do this kind of problem is you write down the labels. Okay. So you have the inch to miles. Okay. So originally giving is 1 to 26, right? So what you do is you write down the label and you line things up. And when you measure it, Okay, you measure is 1.25, okay, and you're looking for how many miles is that. And so once you write down this information, whatever you see, that's your equation. So you got 1 over 1.25 equal to 26 over x, okay? Then you cross multiply, so x will equal to 26 times 1.25, and you get a calculator, and you work it out, okay? So it'd be 32.5 miles. So again, whenever you get confused and don't know what to do, what you do is you write down your labels, and you just write down the number according to its label, and whatever you see, you just put it into equation, and that's your equation. Okay. So again, so it's very easy to do that if you know the trick. Okay. Just write down your labels. Okay. And then whatever the number you just put down in that correct column. Okay. In each scenario, and then you just make into equation. Right, just make into a fraction equal to a fraction, and that's your equation. And from there, you use your algebra, cross multiply, okay, cross multiply, and then you solve. Okay. Okay, same thing. Let's go to example 5. Solve a multi-step problem. Okay, you buy a 3D model of the Reunion Tower in Dallas, Texas. The actual building is 560 feet tall. Your model is 10-inch tall, okay? And the diameter of the dome on your scale model is about 2.1 inch. What is the diameter of the actual dome? So again, whenever you get confused, right? Okay, let's do this, right? So you have the inch and the feet, right? Okay, so actual building is 560 feet. Okay, and your model is 10-inch tall. Okay, now the diameter of the dome on your scale is 2.1 inch. Right, you can just write down none of your label, right? So what is diameter of the actual dome? Right, see that? Okay, so now you're going to just make into equation, right? So you got 10 over 2.1 equal to 560 over x. So you can cross multiply. So 10x equal to 2.1 times 560. Then you divide by 10, so you cancel out. So x equal to 2.1 times 56. Okay, you don't have to do this extra step. I'm just doing that so you can see, how to simplify. So 2.1 times 56 equal to 117.6 feet. Okay? And that's answer right here, right? Okay. It says, how many times as tall as your model is to the actual building? Okay? So how many times? How many times is this as big as that? Okay? Well, first you have to, when you're going to compare, right, you have to have the same unit. Okay? So this is equal to, you times it by 12 to get inches, right? So 560 times 12 equal to 6720 inches, okay? And so that when you divide, right, the 10 cancel, so it's going to be, so you got 6720 divided by 10, right? You're comparing, right? So this is equal to 672. So it's 672 times as tall in the real building compared to the model, okay? So 672. So when you're comparing, you get the same label and then you compare.